the chairs to be functional with the time and then press the speakers as much as possible to be on time.
Okay.
Good luck.
Detto. Let's. Θα το δούμε εσύ μετά λίγο για να...
Μικρόφωνο από εδώ και
Ναι. Α, ναι, είναι για το 2023 για να μπορούμε να κάνουμε πληροφόρηση. Κατάλαβα. Ωραία, από εδώ.
Εντάξει, το μικρόφωνο είναι τέρμα, η ένταση είναι τέρμα.
Ωραία. So your attention, please. This is the last session of the workshop. If you don't know me, I'm Theodoros Kosmanis, chair of this session, which is completely devoted to the project E-DRIVETOUR, that of which the Department of Industrial Engineering and Management has been the coordinator. And in this session, we present a little bit the project itself, as well as some results from the students' work. First of all, I would like to thank Professor Kiziroglu for allowing us to have a fully dedicated session for vehicle electrification. I hope that this will be the beginning of a new cooperation and extension of the initial workshop. So I won't say too many things. The project is called E-DRIVETOUR, an interactive blended course on electric vehicle technology. Many people have been involved in this. Apparently, okay. Now, E-DRIVETOUR is a 3-year project, including 2 years of preparation and 1 year of education, actual education to the students. The aim of this project was the development of an interactive course on electric vehicle technology in general, with a comprehensive and interdisciplinary, as much as possible, curriculum, including various methodologies of teaching, reconfigurable laboratory apparatus, online lectures, experiments physically with physical presence of the students, something which was quite difficult during the COVID-19 pandemic, as well as industrial experience. The objectives including the development of an innovative course on electric vehicles, something quite important, which would be recognized by academia and industry by using the ECTS credit unit. So, credit system. So, each student that was involved in this project actually was awarded with the ECTS 20. So, we have the involvement of students and academia, of course, together with startup and SMEs and some industrial partners. The partnership includes 3 universities: the International University, Hellenic University, the University of Craiova from Romania, and the University of Technology from Poland. For SMEs, Easy Europe from Belgium, E-PROIN, as well as Cercatrova. One research center, the Center of Research and Technology in Greece, and finally, one certification provider, ECQA from Austria. The concept of the overall project was that the educators, instructors, professors, say, this could take about 1.5 years time. At the same time, equipment would be used together with some measurement instructions in order to prepare the laboratory apparatus. So together with online courses, together with the teaching material, we also prepared experiments for the students. The students would have to work on the experiments, to attend the online lectures, and afterwards perform a very short thesis on the so-called demonstrator, which for which they will give you some explanation in the forthcoming lectures. The demonstrator is a small-scale electric vehicle on which the students had to work on. So after this second step, the third step would be the industrial experience of the students in one of the industrial partners in this project. Overall, after some appropriate exams, the students will be able to receive a certification for the skills that they have acquired during this project. The teaching topics. Let's say that can be divided in various subsections. First of all, the core electric vehicle technology, which are electrical topics. In the core electric vehicle technology, electrical topics. In the core electric vehicle technology, mechanical topics. Then we have some other EV-related topics like an introduction to vehicle electrification, autonomous vehicles, smart griding, etc. Electric vehicle business topics. That is why we say that it is a multidisciplinary course. So we include electric vehicle public policies, life cycle assessment, production management, business administration, totally focused on the electric vehicle market. Cultural topics, Greek language and culture, Polish language and culture, a few hints from these languages, and finally, 2 small-scale, medium-scale, I would say, projects on augmented reality and a final project which includes this, the paper that will be presented. So here you can see the courses are divided into 2 slots, 2 periods, I would say. In the first period, 11 courses plus 1 intermediate project. In the second period, the exact same format, 222 working hours during the first period, 218 working hours in the second. If we include 14 days of practical experience, which correspond to 80 working hours, then we have 520 working hours, which also correspond to the 20 ECTS that are awarded to the students. Regarding the participating students, we started with the selection of 40 students. These students were reduced to 36 when we actually started on February 2022. And then after various reductions, we reached a number of 28. This was the number of students that have participated in the exams. So far, one has succeeded. Hopefully he is here, and congratulations about it. And the remaining 27 will repeat the exams next week. The teaching format included 3 to 5 teaching hours daily in the afternoon for about 4 months. 2 teaching mobility periods, for which I'm going to speak shortly. 1 practical training mobility period, and the development of an e-learning platform to support the overall project. The teaching mobility were 2. 1 in March 2022 in Thessaloniki, then May 2022 in Radom, Poland. 35 students plus 24 educators in total have participated in these mobilities. And the practical training mobilities for different periods to host all these students from the industrial partners and the research center involved in this project. During these mobilities, we had the students work only on laboratories. So we had in Thessaloniki data acquisition and TV sensor labs, national instruments lab training, electric vehicle energy sources and energy storage systems, lightweight material, autonomous vehicles, and electric vehicle motors and motor drive. And during the second period, electric vehicle charging systems, onboard diagnostics and maintenance, mechanical drivetrains and vehicle dynamics, all of them appropriate for electrical vehicles. Finally, during both mobility periods, the students had to work on small-scale electric vehicle prototypes, the ones that we have here at the university, as well as augmented reality software here as well as in Radom. Some photos from selected labs here. Some of you might recognize the places. Here we have the lab about lightweight material. It was the first time we did that, together with the result. A lab on autonomous vehicles. Also, a few things about Greek language and culture, which was practiced in the city of Thessaloniki appropriately. And finally, during the last day, we had a real electric vehicle coming from the Center of Research and Technology in Greece, which was the students investigated it, served every part of it, and we had the last picture of the first mobility period. In the second mobility period, things were more or less the same. We had the augmented reality lab. The students have worked with an electric vehicle prototype, did their onboard diagnostics on a Toyota Yaris hybrid, and some cultural activities, which was part of the pleasure that always accompanies this mobility period. During the third mobility period, the students were divided into 4 groups. One group came here to Thessaloniki to work with Interlink, the CERT, and here at the International Training University. Another group has moved to EASY in Poland. A third group to E-PROIN in Salerno, Italy. And finally, a group of students to TRIGO, a group producing electric vehicle prototypes in Poland. After all these procedures, we had the certification exams. They are divided into 3 parts. Each of them, of these parts, examines the knowledge of specific topics from the overall curriculum, and the final certification will be provided by ECQA, which is a certification provider company from Austria. In the frame of the project, various materials have been produced, like website, social media, the e-learning platform, some technical publications, participation in forums, events, workshops like this one, promotional material. And finally, I have to say that the effort is not only to conclude with this specific project, but continue and develop, found, I would say, a master's course on electric vehicle technology, hopefully among the first in Europe. Increase as much as possible the connection between academia and industry and the electric vehicle market, and in parallel with all this, to the development of an accredited vocational training program completely focused on professionals. So these are our goals, a short-term goal to include as much material developed so far in our curriculum. So in the undergraduate and postgraduate course of electric vehicle electrification, we have included several labs from here, several experiments. And the long term has to do with the expert program and the development of the master's course program. That's all. Thank you very much. And now we can proceed with the presentations from the students. The first one will be Stella. So the first leg, the second presentation is from Mrs. Stella Karasakalitou. She's, let's say, the representative of Group C of the students. She represents 6 students in total. So Stella, please.
Thank you for the introduction. As Mr. Kuzman said, I'm an undergraduate student of production engineering management here in Nepal. And in this capacity, I'm participating to this training program. We already mentioned that we were divided into work groups. I was in Group C, and I'm here to present the 2 intermediate projects that we were assigned to fulfill. Before that, I would like to say a few words about how we have come to this, and maybe what it means for our community. Back in the time, in the late 19th century, the first successful electric car was made, but it wouldn't be publicly available because it wasn't affordable. And at the same time, the conventional car was made, starting with the T model, and that conventional car, which is the internal combustion engine car, took the lead and dominated the automotive industry. So the electric car didn't stay behind exactly. It stayed behind, but the electrification as an appliance didn't stay behind. The electrical evolutions never stop growing, and many times inventions help the assist the internal combustion engine cars with inventions like the French Mies, we all know, which is the starter of the motor of the engine. And furthermore, heavy-duty machineries was developed and widely used in the industry indoors, like forklifts in the logistics, different various motors, appliances for power transportation and storage, many small and big inductive motors for domestic use, like tools like screwdrivers, many other tools. So my point is that electrification as an appliance never stopped. And turning back to our time, the last decade, we're facing an intensive climate change. And the political system promotes and secures a legitimate funding to the electrical solution. And that is a very happy occasion. Even more happy occasion is the fact that we didn't start from scratch to invent an electric car. The technology is here, and in a very simplified way, we just had to combine the different achievements we had so far to adjust them and improve them all over again. So we came to the electrical solution fast. So we managed to grow this industry, and the electric vehicles have gained important share market in automotive industry. What we are doing here is we try to involve more human resources in the total effort. That's a way to spread the knowledge, to secure the so-called human capital, and to enlarge it even more. So back to the intermediate projects. In the first intermediate project, my group had to electrify a 50cc scooter, which is the one in the picture. The steps we took was to take apart every component of the scooter, to find out what we had, and then to see what we were missing in order to complete the necessary components for the powertrain. So we found the controller and the motor, and we put labels on each component. We took enough pictures in order to help us reassemble the powertrain afterwards. So we didn't have the battery. We ordered the battery. We brought we used the data from the components we had in order to order the appropriate battery to cooperate with the rest of the components. When then we complete the reassembly of the powertrain, and it was time to design some applications that makes the use of the scooter friendly and fancy to the user. First, we designed a 3D model of a similar bike, which is shown in Tinkercad platform, which is an open source platform for various applications. We also designed the electrical circuit of the bike. And there you can see there is a rate sensor using an Arduino board. The sensor, the range sensor was a necessity for a bike because it is common among electric vehicles, and it's very useful to have one, especially when you have a scooter, a bike. So the next step was to develop an application where the user would be informed with live data from the session via the internet. That was actually finished, but we couldn't build in the full application to the scooter because we were run out of time. The second interaction with the user came with a QR code through the OpenSpace 3D application. OpenSpace 3D is an augmented reality platform environment that lets you build an application for mobile phones. You put a QR code on the bike, and the code is readable from your application, and some content pop-ups in 3D dimensions. And that's very attractive and amazing at the same time. That was the first intermediate project for my group. In the second mobility period, we had to present a hybrid model of Toyota Prius 2004. Toyota Prius has two power sources and two coolant systems. The first coolant system is placed on engine, and the second in the inverter unit. And we have two coolant systems because engine and the inverter unit operates in different temperatures. The engine and the power source, the two motive power sources are the petrol internal combustion engine and the electric drive system. The operation of the two sources alternates in a smooth and continuous way, and that is mostly the cutting edge of this model. The internal combustion engine is a four-stroke engine. It's based on Atkinson cycle, which is designed to provide great efficiency and very good economy. Its peak output can reach 57 kilowatts at 5,000 RPM speed. On the other hand, the electric drive system is consisted of a power source, which is a battery, a 200-volt battery, an inverter unit with multiple functions, as I'm going to describe it further, and the motor. The combination of the two motive power sources result in fuel efficiency and low emissions, less emissions in comparison with the traditional automotives. And that's because the power sources contribute both the traction force on the wheels. The motor is a synchronous 8-pole AC permanent magnet with peak output power 50 kilowatts at 1500 RPM speeds. and maximum operation voltage at 500 volts. So the motor is mainly powered by the battery. So there is a need for a bidirectional back and boost DC converter, which is in the inverter unit that boosts the voltage from 200 to 500 volts. And then a DC-AC converter that provides a three-phase voltage to the motor. The back function of this converter is used while charging the battery from the generator, which is powered by the engine, or while decelerating and braking through the regenerative system of this car. The generator is an 8-pole permanent magnet AC device that functions as the engine starter. It produces high power density and then makes it capable to charge the battery and also supplements motor's power needs at the same time. The major transmission device of the model is the split device, which splits the mechanical power from the engine shaft, rotating the generator and the wheels at the same time. The split device practically is a planetary gear set, as we see in the picture. More data information and detail are written in the article itself. What is important to remember is that in this hybrid model, the motor supplements the engine when the efficiency is low and generates electricity when the engine efficiency is high. And in this way, the system achieves the best efficiency. To complete that thought, I would like to show you a short video with the power allocation. This is the augmented reality of the hybrid model. So, okay. Finishing my presentation, I would like to express my gratitude to the professor that gave me the chance to participate in this training program. I personally evaluate the program of great quality, and I believe it is an excellent way to not only to participate to this promising evolution, but also to contribute to have a say through our work as much as we can. And that's very important to our community. Thank you so much.
Now we proceed to the next presentation by Mrs. Maria Michailidou. She represents Group D. Yes.
So, hello, my name is Maria Michailidou, and I'm here to present medium-scale projects as a means for educating students on electric vehicle technology. You can actually see all the people who comprise Group B in the title there. Okay, so as it was presented before, the E-DRIVETOUR Erasmus program was a program which had as the main focus the education of undergraduate students on electric vehicle technology. And we were divided into groups, and this presentation is actually about Group D and the work that we performed over the duration of 2 mobility periods, one here in Thessaloniki and another one at the University of Technology and Humanities in Radom, Poland. So actually we were assigned the Type 4 drive vehicle by the Electric Vehicle and Automotive Electronics Laboratory. And at first we performed some pretty basic mechanical and electrical maintenance and proceeded to write the necessary documentation of all the relevant technical data we could find on the vehicle. Then we actually went ahead and 3D designed the vehicle in a cab environment according to real-life dimensions as much as possible. And then we used that 3D model, which you can actually see in the picture, in the OpenSpace 3D program to create an augmented reality application, to create an AR application. Okay. Unfortunately, we had some issues with our electrical maintenance. So we had to create a circuit with a potentiometer and the Arduino microcontroller to simulate the float pedal of the vehicle. And then after we had established the circuit and connection between the circuit and the augmented reality application, if someone went ahead and changed the potentiometer value physically, the throttle value that you can actually see here would change in real time. Okay, so for the second mobility period, we were assigned a much more complicated vehicle, which was the Toyota Yaris Hybrid 2020 edition. And thankfully, we were able to collect all data that is presented through the connection of the BOSS diagnostic tool to the car's OBD4. And it should also be noted, and you can actually see the supervising professor driving here, that any procedures we performed on the vehicle was made under strict supervision because it was really expensive and we didn't want to mess something. So one of the experiments that we did was actually on regenerative braking and how that is done on the hybrid vehicle. And we actually observed that whenever the brake was pressed severely, the battery recharged about 1 to 2% of the overall state of charge. And also that after reaching a certain value of regenerative braking torque, the rest of the braking energy produced is absorbed actually by the brake pads. So if someone wanted to come to a full stop while they were going at 30 kilometers per hour, the electric motor couldn't just brake by itself, but it needed the help of the brake pads to go ahead and come to a full stop. Okay. And then we actually went ahead and had another set of measurements for the electric vehicle mode only of the hybrid. So this mode pretty much deactivates or doesn't use the internal combustion engine of the vehicle and powers and moves the vehicle strictly to the electrical motor, which is powered by the battery. And a really nice value is actually the maximum motor speed we were able to reach at 2,800 RPM. And that is on an automatic transmission, proving that the electric vehicle mode only is just as powerful as a commercial gasoline-powered vehicle when it comes to speed, because you can actually see here that there was no torque output on this set of measurements. So we actually then went ahead and designed the battery in 3D. You can see the pretty common battery of 12 volts for all the low voltage devices that most conventional vehicles have. And you can see the hybrid battery, which is comprised of nickel metal hydride batteries connected in series, which in total is 144 volts and weighs about 31 kilos. So here I briefly explained that the hybrid battery is charged from one of the motors, while it provides power back to a second motor and the inverter and the compressor of the vehicle, which is needed for its cooling. And we actually went ahead and 3D designed the engine as well. You can see the internal combustion engine here, and more closely, you can see some of the pistons as well, plus the planetary gear, which, as Stella mentioned, is present in this vehicle as well as a powerful device. And of course, the two phase motors of alternative current right here. Yeah. Oh, actually, this is all. Yeah. And the planetary gear is here. There are a lot of people who know about vehicles in the crowd, so I'm not worried. Thank you for your attention, and I would love to hear any questions that you might have. Yes?
What is the capacity of the hybrid battery?
I'll have to check the manual. I have to be honest.
Okay, thank you, Mara.
It is about 10 amp hours, 10 kilo amp hours. Somewhere. So next presentation is from Mr. Dragos Siciumariu from Romania. He was a member of Group F. So, and he will present actually the results and findings from his from the group work.
I will present directly on the paper, the laser pointer or something. Okay. Hello everyone, my name is Dragos. I'm a student at the University of Craiova, and these are the members of my team, Prepare. And this is our point of view of what we did on this project. So, starting with a bit of information about the domain that we studied in. As you know, electrical vehicles are becoming more and more used by everyone, especially now since the, let's say, political environment with the prices going up, less fossil fuels being available. People tend to navigate also pollution, of course, and climate change. People tend to pick electric vehicles or hybrid vehicles. As such, it is important to have a course that prepares people, especially students, this domain. As I said in the introduction, I have presented a bit of information regarding electric vehicles and plug-in electric vehicles, hybrid vehicles and plug-in electric vehicles, and the E-DRIVETOUR platform. It aims to teach students, as well as remotely and on-site in a multicultural environment, about the current technologies. as said before, the project has been going on for 3 years. And the last year was the year that the actual teaching has been going on. We had the first part, and in the first part, we did online courses. And after that, we had the second part with the mobility periods, 2 of which were hands-on laboratory practice. The last part, the third mobility, was more special, so to say, because students could pick at which company to go, and then they would do work in that startup to see how people actually work in an environment, a professional environment, where they make something, they produce something. The courses, they were structured in a 3-hour format. We had breaks. If we had questions, we would interact with the teachers. At the end of them, we had little quizzes, little problems to solve. So it was very, very interactive, and we could solidify the information that was presented to us very easily because of that. Just to present each mobility period in part and what we did on them. The first mobility period was, of course, here in Greece, in Thessaloniki. I like it a lot because we got work from the number of electric vehicles. We even had a mini race at the end of it where students could compete with electric vehicles they worked on. We learned a lot of things. We even had simulated errors introduced. A defect cell in the battery. We were supposed to find it and to figure out that was the problem. We also had a problem in one of the wheels. And we had to fix it. So it was very, very interactive, very, very nice. At the end of it, we did something that I haven't done before and my team haven't done, and that is a presentation in open space 3D, where we had to make a model of the vehicle and present it in a new way with augmented reality. The second mobility period was in Radom, Poland, and we had as a focus more towards hybrid vehicles, and more specifically for us, it was the Toyota Yaris. And we did different measurements of the sensors, and some artificial errors were created for the students in order to see how they are diagnosed and how they are fixed. In conclusion, I'm just gonna say I really like the course. It was very, very nice for everyone. We saw different approaches, different people, and it was very nice. Thank you all for having me. Thank you, Mr. Kosmanis. Thank you, Mr. Georgioumis. It was very, very nice.
Thank you. And the final presentation is from the students of Group A. Unfortunately, we don't have all of them here. All the Greek students is Karyophilis Kakidis, Anastasia Irini Georgiadou, and George Diamandis. You may start.
Mr. Professors and colleagues, my name is Karyophilis Diakidis, and I am a student of the Department of Automotive Engineering at the International University of Greece and part of Group A of the Erasmus Plus program, E-DRIVETOUR. In the following slides, me and my team will present you and analyze the program, followed by 40 students, only 28 came to an end. from Greece, Romania, and Poland. Specifically, we're going to present you the work of the Group A. Group A is consisted of 6 people, me, Anastasia, and George, and also is Alexander Pavel, Maciek Barskowski, and Sori Radu. The last 3 parts of the team, they're not here due to university obligations, but we thank them a lot about the effort they offered to our team. E-DRIVETOUR Erasmus Plus program aimed at introducing undergraduate students of the 3 universities to the electric vehicle technology. It consisted of theoretical lectures on appropriately selected topics on electric vehicle technology, laboratory courses taking place at the premises of the International Hellenic University and the University of Technology Humanities in Radom, practical training, and 2 medium-scale projects. The projects were entitled as Intermediate Project 1 and 2, and the students had to work on them on international groups. Their content and purpose are presented in the following sections of the paper.
Hello, I am George Yamatis, and the purpose of the first project was that the student had to work on the familiarization of each component and then understanding the working principle of the Delta strike bike. In order to do that, firstly, we had after determining how the Delta works, we had to identify all the components, research for them, and after that, we had to make the bicycle again functional because some of the parts wasn't working, and create a 3D model of it. The creation of the 3D model was made in OpenSpace 3D, and we used also a mobile application in order to make a representation of some components and the Delta strike bike and provide some information about it. The main components of the Delta strike bike was 2 wheel motor, the brushless DC motors, 1 Arduino Omega, 2 batteries, 1 clinometer, and 1 throttle potentiometer. After carefully examining all the components, the team searched for some problems that cause the Delta strike to malfunction. The first problem that we found out was a burnt fuse and a relay that was not switching. By replacing all the damages, we were able to power on the system, but unfortunately, the motor wasn't working. And we checked for the wires and the motor, and we found out that there was a defective transistor in the system. So we replaced it, and after this, the strike bike was able to work appropriately again. And finally, we made an application in order to solve it.
On the second intermediate project, we worked on a Toyota Prius hybrid vehicle. As a hybrid vehicle, it was much more complex, so we had to search and find some information about its components. As you can see in the figure 3, there are the components. It was a planetary gear, internal combustion engine, electrical generator, boost converter, electrical motor, and the battery. After we found the information, we worked on an OpenSpace 3D software to create 3D models about the vehicle and all components. For this 3D space model, we used push buttons to select and see information and some papers about the 3D model of the vehicle and every component. Also, as you see in the figure 4, is the initial screen, and you can see the 3D model of the car and the push button.
The objective of 2 intermediate projects has been achieved as the students have learned how an electric trike and hybrid electric car work in general, as well as about the operation of individual electric vehicle components. The experience gained out of these projects was not only theoretical, but also technical, as the students had the opportunity to work on real-life electric vehicles, disassemble and measure various parts of the electric vehicle used. The on-site laboratories and online courses done prior to or during the time frame of the projects have significantly assisted the overall learning process. We have to thank all of the professors and the students for the effort they have taken in order to come to an end this program. Thank you very much, and thank you for your attention.
Any questions? Thank you very much.
Thank you very much. Thank you.
We have to say that the overall session is not research. It doesn't have to do with research, but it's mostly educational, strictly educational, on an up-to-date scientific area like electric vehicles. All four presentations coming from students were more or less alike, because they were working in different electric vehicle prototypes, but the work that they had to do was more or less the same. So thank you again for attending this session. We hope that in the future it will be enhanced by including again educational projects, but also research work as well. And we should call Professor Kisiroglu for the award that will be given. Thank you again.